See what the thanks, Joe. He's back here. Leave him there.
Reg,
Hi,
you're gonna have good weather tomorrow.
it's gonna, well, I tell you, it's gonna be beautiful after about 10 in the morning, sun coming through. The angels will sing.
Not good enough.
Yeah.
No.
Randy messed up. His eclipse was too early. It's all his fault.
So for those of you who still want to see it, I'm just going to put in the time and date broadcast into the chat. If you're still up.
Yeah, it's quite incredible though, as Reg is saying. I mean, it's, according to this cloud forecast, yeah, it's supposed to just be crystal clear.
Well,
Bye.
last week I recklessly made a forecast that we would be clearing out tonight, but as the data can continue to come in, I worry more and more. And then it's the strong outflow developed as predicted, but we have some residual cloud here until tomorrow morning. So we'll have some showers or flurries overnight, and it'll ease off towards daybreak.
That low off the Oregon coast just doesn't want to move.
It'll slump southward, and I tell you, it'll be joyous tomorrow.
Okay.
People will be whistling as they shovel the snow.
Or not. Very good. How are we doing? So just on the half hour, maybe we'll just give it another minute or two to let people, as I see, quite a few people are arriving. So welcome everyone. We just continue to chat for a few minutes.
By my place, the roof is covered in snow.
Yeah.
When I drove here, there were kids trying to make a snowman outside.
And actually, maybe I'll just go around. So I know we're going to hear some of the from the Astrophotography SIG. I believe so. Brock, I think, is going to lead that. Does anybody else want to speak tonight or have anything to show us? And remember that David has shared a link in the chat if you want to at least watch a feed of the eclipse in the wee hours, because yeah, we won't get to see it ourselves, it looks like. So anybody else? David, do you have anything, any SIGs this week, or are we?
No, not really. I think I think the next SIG is probably a maker's SIG. I think that's on the probably the 17th, and then of course there's an Astrophoto SIG actually.
Right.
Third week of or third Wednesday.
Right.
Fourth Wednesday, Dave.
Oh, sorry, fourth Wednesday. I don't run it, that's why I don't know. Oh, actually, there is a small thing I'd like to talk about is since we've been doing things like the sky brightness survey, I just wanted to see if there was any interest in forming a group looking at citizen science initiatives. I'm not sure if people understand the breadth of citizen science, but it's such a quite varied. I've looked into it over the years, and I haven't participated in all of them, but I've tried a few. And the sky brightness is kind of a more active and localized version of citizen science, but there's very broad ones that span North America, and there's kind of like data mining exercises. There's identification exercises. So I think I might do one just to see if people are interested, and just to give people a description of the kinds or the breadth of what you could actually do. But yeah, let me know if you're interested. I'll certainly be happy to sort of form a quick group. We wouldn't necessarily meet that often, but maybe quarterly or something like that.
Yeah, maybe if you could give it some thought and maybe even talk a little further at an Astro Cafe one evening, and then we.
Yeah, I guess that's the way I could do it. I maybe if you could maybe give me 15 minutes, some future cafe, I could certainly do that.
Yeah, that should be fine.
Hmm.
Okay, well, I think we'll get started. Welcome everyone to the Victoria Centre Astro Cafe for the first one for November this year. I was alerted to the fact we've got at least one new member, so I'd like to welcome Gordon this evening, who's recently joined us. If you want to say hi, or but welcome. And so right now we have so on the agenda for this evening, we're going to have a talk with, I think, Brock leading it on some of the astrophotography that's been done. And so I think we're ready to start that if you are, Brock.
Sure, I could get going here. Just give me a moment. Didn't expect to be on point, but I'll be fine.
Yeah, well, I think you might be almost it tonight. But
Oh well, I should have added a few more pictures.
and just while Brock's getting started too, we're using the term SIG, which is special interest group. So this is a subgroup of members who have been meeting. When did we start those, David Lee? Was it kind of last year, I guess?
Yeah, we've been doing them for a couple of years, I think.
Over a year now, yeah, maybe even two.
Yeah,
Yeah, so,
almost two.
So special interest group. So this is one of the groups that's there.
Can you guys see the shot of Stefan's quintet?
Yes.
Excellent. This is the first image of our series for tonight. This one was taken by Dan Posey at using the Plaskett telescope up at the observatory, and it has all of the power of the Plaskett with all of the wonderful flaws that in the sensor and stuff which give it some character. This I don't know if Dan's here tonight. Are you here, Dan? I didn't really check. Didn't see him. Okay, that's fine. I'll speak to it as well as I can. It's actually a beautiful group of galaxies that are shown here. You can see Stefan's quintet is this series here, and there's an additional galaxy that's in the field, but is actually quite a bit further into the foreground by, I don't remember the exact numbers, but it's nowhere remotely close to the other galaxies. It's almost like halfway between us and them or something. But it does appear like it's part of the group, but it's got a slightly bluer hue to it, which I've been told is partly due to the fact that the more distant ones have a greater redshift, and it could also just be an inherent color difference in the galaxy itself. But it's a great shot that Dan managed to capture, and the processing, anyone who's worked with data from the Plaskett really has a lot of respect for the work that Dan did on this, because it's very challenging stuff to work with. So there's another little galaxy here, which I don't know, I'd have to dig into it. I don't know if that's part of the same group of galaxies, but it's a little, looks like it might be a barred spiral. It's kind of hard to say, but beautiful shot. The next one is also, I grouped Dan's stuff together. So this is another shot using the Plaskett of the ring nebula, Messier 57. And there's also, if you get really good images with the ring nebula, there's also a small, well, not necessarily small, but a faint galaxy that's not far from it in the field of view. This one is particularly good in that there's quite a bit of detail. If you've ever tried to look at or photograph M57, it's quite a tiny object in the field of view, and to get that much detail, it definitely helps to have the Plaskett. And he's even picked up some of the halo. There's a halo of hydrogen alpha emissions around it, that if you get enough exposure time, you can actually bring that out. And there's a lot of potential, even more detail there if you could get more time on it. And this one is another of Dan's, and this is the Iris Nebula and the region around it in Cepheus. And there's actually, it's a beautiful image, and there's all this dust. And there's, in fact, I don't have it in tonight's show, but there's one of the other SIG members actually captured almost this exact view here of the Ghost Nebula, which is a great nebula for a period around Halloween, which we're a bit past, but it just goes to show how much is going on in this field of view that Dan captured. This wasn't with the Plaskett. I think Dan did this with his smaller telescope and probably his Canon RA or one of his other cameras, but a really good shot. And of course, the detail in the Iris Nebula and all of the dust around it. It's a reflection nebula. So the star inside there is basically lighting up with visible light all of the dust that surrounds it. Next on the list is Ron Fisher's nice shot of the heart and soul. Are you on the call, Ron? I'm not sure. It's going to turn out everybody except for Dave Payne and I aren't here, maybe. I don't know. But Ron's been really gaining traction on his equipment, taking pictures with a small refractor, and I think he's also using a DSLR along with that refractor. And so this image he took has the Heart Nebula here, and it also has the Soul Nebula, and there's a decent amount of detail. And you can see later on, I have an image just for reference point. I have an image that I'll speak to later that I took, and it's in the center of this guy, just so you have a sense of the space. But this, of course, Heart and the Soul Nebula are areas with a lot of young stars forming in the center that are, of course, pushing out and exciting all the surrounding dust and gas in their various neighborhoods. And there's another nice shot Ron took recently of the Cygnus Loop, which of course is the Veil Nebula. And as Dave Payne pointed out, the Cygnus Loop is essentially a large bubble, and you can actually see there's a bit of a ring shape here, which is kind of like a tire that's sort of slightly turned sideways, so it's more of an oval, but it's kind of the structure of this loop is expanding gas from a supernova, and you can kind of see the stuff appears to be in the foreground with the other side of that sort of oval more in the background, and then the shock waves that we're sort of seeing edge on heading outwards as those gases expand and push other material out.
Brock, is your description, I've never heard of that. Is that something that's based on other evidence, or or are we hypothesizing that it might be like that?
Well, actually, Dave Payne found some, I don't remember where it was, but it was both some detail in his image and then something that was actually published somewhere that showed a bit more about that detail, about the fact that there's that sort of open loop kind of shape to it. I don't know if Dave wants to speak to that himself.
Sure. There's actually a shock wave, and it's pretty faint in this, but you can actually get the outermost shock wave of the actual supernova, and you can see that it is round. And a lot of this material didn't actually originate in the supernova. It's been pushed out along with this shock wave, and the shock wave tries to find the easiest path around it. But basically, it's a sphere.
You know, it makes perfect sense. It's just that I often you don't see enough exposure, so you don't get that three-dimensionality to it. It's to me, it's always been a very flat object, and often you would only see pieces. You would never see all these pieces. So that's that's a good insight.
It needs a pretty wide field to see the whole thing, but it kind of brings it all together. When you see the East Veil and the West Veil and all these bits and pieces, it doesn't give you the full the full scope of it. So it's a nice image. I think the next one is Ken McGill. Are you here tonight, Ken?
No.
I think you're. Did I see you? I think I see you sitting in the lounge there. Do you want to speak to your shot of M33 Triangulum Galaxy?
Yeah, that's a triangulum galaxy. I eliminated a lot of subs from this, and I think there's 26 subs on that one now. 300-second subs, 5 minutes. It's fairly rough editing. I was actually working on that today. I have a total of 51 that I didn't reject. So I'll be fixing that up a bit. But I think there's about 40 billion stars in the Triangulum Galaxy. And yeah.
Nice. Nice
If I can
framing
just-
too.
If I can just interject here, Brock, we've got to give kudos to Ron and Ken. They just started this and look what kind of work they're doing.
Oh, for sure.
So this is a bit of a commercial for the beautiful system the tech committee's put together for everybody, not just people in the astrophotography SIG. We'd love to have you use it, and you get a lot of support from the folks in the SIG to actually do stuff like this. This is lovely, and you could do it too.
Yeah, it's a great help.
Excellent point. The next one.
Dorothy has a question, I think. Dorothy, did you have a question? Because your hand is raised.
You're muted, Dorothy.
Yes,
Oh, there we go.
I'm trying to unmute myself. I just want to say they're great pictures. I've looked at all these many times through a telescope, and they're great. They of course show more detail. For someone who hasn't looked, for an observer who hasn't looked at these a lot, though, they could be confusing because they're inverted from the sky map directions, and it would be nice to always indicate which way is west, specifically or particularly for the ring and for the veil. And in the veil, you actually can follow a whole circle just about if you have a good sky. So it augments what the visual observer does, but it helps to have the orientation the same.
Yeah.
So Dorothy, you're saying that you can actually see the ring visually?
Now through a telescope, you follow the ring. The ring M57?
The ring that's in the veil.
You can follow it. It gets very wispy and faint, and with maybe some averted vision, averted imagination, tiny breaks. But if you keep moving, you can get a greater sense than one might think from a quick look at the veil, which is always impressive, whatever telescope you can spy it with. Nice photographs.
Yes, Dorothy, I was just gonna add, like, I'd love to see people, if you've got your set sort of browsing for astronomy news or something, just include that our Zenfolio site in that. Love to get more eyes and more of the group seeing what the SIG guys are doing, because it's really fantastic, and I just look at it as exploring space with the camera. So
yeah, I really like the fact that there's a high element of synergy in what we do. I hope that this isn't just about photography, like that we learn a lot from the imaging, and then the imaging people learn a lot from the people that have been observing as well.
Oh, for sure.
Can somebody kind of go through what happens during an astrophotography SIG? I haven't been to one. I don't do this stuff. So what's the nature of the discussions?
Well, typically we explain what we've done, but we also venture into the technical part of, how did you take an image? What do you do to solve this problem or that problem? So it's 50% astronomy and 50% tinkering.
Yeah. But we have to explain how we get there. So that involves the equipment we use.
Yes.
Sensors, the processing, and invariably we get buried in problems. And that's where we learn.
There's also
from each other.
Yeah, there's also new techniques as well. I mean, a lot has changed over even the last 10 years. As Joe mentions, there's new sensor technology, but even processing, like we've seen a lot of leaps and bounds in terms of the software.
Yeah, things.
Yeah, and don't forget to mention Dave's new thing that's now a part of PixInsight.
Yeah.
That's significant, one of our own guys has got something up there, like, attaboy, Dave. So just for you guys that don't do this, Dave has come up with a new routine for working on these pictures that now everybody in the world is using. And it's pretty cool, actually. Very, very cool.
It is. And it's not just in PixInsight, it's also in another.
Well, that's right too.
It's in Searle, which is another astro tool. So.
And Dave, did that come from your work in your occupation, that your previous occupation, or what? How did you get the idea for it?
Yeah, we use it a lot of time in forecasting production but it's also used in economics. It's used in a lot of scientific fields for forecasting natural processes, and it's usually as a time series. So I took those equations we use for a time series and sort of morphed them into something that actually brightens the pixels, because when you take a picture, it's generally very dark. All you see is the stars. You don't see any of this nebulosity or anything because it's so much darker. So you want to have a technique to brighten all this background stuff, but not over brighten the stars. And that's essentially what it does. But yeah, it's been a lot of fun interfacing with people. I'm giving a talk to Hamilton Center in the new year, and I'm giving a talk to the San Jose Astrophotography SIG, their equivalent, in December here. So lots of fun.
Good going.
So as I would think, we could jump back to Ken's image here. We're talking about his triangle image. Ken also did a really nice job on this elephant's trunk. And I had a hard time, as I went to go get this for tonight, I actually realized he's got a couple other versions. So they were all a couple others that were sort of trying to decide which to show, but this one is particularly nice. And of course, Elephant's Trunk Nebula, there's beautiful sort of pillars of dust clouds and hydrogen emissions and stuff, and some dark nebula in there. Did you want to speak at all to this one, Ken?
I think you've said it all. I must say I'm trying to learn GHS right now.
Yeah,
I'm absolutely amazed at the work you've done on that, Dave. Very impressive.
Well, thanks, Ken.
And the next shots, I don't know if John McDonald's here, but we're getting a repeat on the Ring Nebula. But this is also a promotion of our Victoria Center Observatory, because John was up there. I think actually maybe David Lee as well, the co-conspirator on this image. And that was, I don't know if you want to speak to this one, David. I don't know if John's here, if he wants to speak or if he's.
I don't know if John's here. Yeah, this is actually one of the probably early images that we've taken with the new camera. I don't know if everybody's aware of the camera that we have, but it is definitely kind of state of the art. It's a QHY 600 PH. It may not mean a lot to people, but it produces massive files, but it is an extremely good sensor. We sort of paired that up with the 12.5 inch OGS scope that we have as well. Thank you to the people that have sort of contributed to that. I would say that the VCO is pretty well ready. We've been sort of kicking the tires, so we've been a little bit cautious, but yeah, we've been exercising the equipment, and this is certainly just one of the results. And this is not a super careful capture either. So I think maybe that's also a testimony to the fact that we're not really even trying yet, and we're getting some very nice results.
Yeah.
Could I ask that speakers not use initialisms and instead say what you are talking about? Because the new person and even the ignorant old person like me don't know what you're talking about.
Is there anything you would like me to explain?
All of the initialisms that were just used over the past 10 minutes.
Over the past 10 minutes. Well, I'm gonna have to catch up with those. I'm okay.
Ken mentioned the GHS program. That was referring to the program that I put together that we discussed earlier.
Yeah, and the trade name of the camera is not super important, but the camera is a very sensitive sensor. It's being paired up with a very relatively large telescope, if I want to sort of simplify it. And yeah, we're ready to go. It's a monochromatic camera, meaning that there is some work in the sense that we actually photograph through separate colored filters to achieve the color effect. So we will photograph through a clear filter, photograph through a red, a green, and a blue. And that basically gets assembled when we quote process the image to get combined together and to produce this color image.
And you recall Ken said that he had a certain number of subs. Well, those are sub frames. They're separate pictures that are typically like 300 seconds long, and then they're all combined one on top of each other to give you the picture that you see here.
Yeah, and the reason why we do this is any single exposure may not be sufficient to gather all the light that's possible. So there's a technique that we use called stacking. And the stacking is the accumulation, the computer accumulation of all those maybe 300-second or 60-second images. They're combined together to sort of reinforce the signal that's there to produce excuse me, things that are maybe dim, they become much brighter. I hope that covers a lot of the questions about any kind of obscurity that we may have introduced.
I think the thing to note also about this image in particular is the ripples inside the red ring are quite difficult to normally tease out. So the data here is particularly good from this setup.
Yeah, as well as the two stars in the middle. When people photograph this with smaller equipment and maybe less precision, the two stars aren't always visible.
And visually, this would just be basically a smoke ring, a monochromatic smoke ring. There wouldn't be any detail visually unless possibly Dorothy would see some detail if she was at the dark site using a large aperture but very difficult to observe visually.
Yeah, and in terms of type of object, this is a planetary nebula.
Yeah, the star in the middle is actually the dying or dead star. It's now the size of about the Earth, and hence the name planetary nebula. It doesn't have anything to do with being a planet or
Right.
anything. It's just a planet-sized star that's had its nova.
I have a naive question. If we just look at the stars, they are points. There's no way of resolving any dimension to them, and yet they're all different sizes.
Yes.
What determines the size that you see in an astrophotograph,
The brightness, basically.
and why?
Because the it's a number of things, but it's the blurring and it's the amount of light that comes from that blur, or whatever spreading factors are happening to sort of shake the star around. And the more light it's putting out, the more that essentially exposes. And it's also, there's a certain element that also happens where you can overfill a pixel and it'll spill out into neighboring pixels.
Yeah, this was actually more apparent with older sensor technology, but most sensors today have what is called anti-blooming.
Yeah.
So it prevents the spilling of those photons because people are basically taking pretty pictures, right? For scientific use, people don't use that, but they are very careful not to overexpose. And
there's another explanation too, Randy. I used to work up at the observatory with people that designed adaptive optics, and it's something that takes the twinkle out of stars. I know that sounds unromantic, but all the stars that you're seeing here, they're all, but if you look at it, if you take about 1,000 pictures a second, which they do with adaptive optics, you can see the star tracing a random pattern that after a couple, after a second or so, it just simply is a circle. It's a random pattern, like a bee buzzing around. That's a circle, and all the stars are moving around the same amount, but the bright ones, when it's way on the outside, when it's there rarely in the circle, that shows up if the star is bright. But if it's a dim star, it doesn't show up. So basically, all the stars are moving around the same, like little bees, but the brighter ones, it shows up better farther out. That's why they're bigger.
Yeah.
And at a more basic level, another explanation for the stars not being points is it's entirely possible this image isn't in focus completely.
Yes.
And
but there's very point-like objects in this picture.
They're just dimmer.
Yeah,
but they must be focused or you wouldn't see them.
Well, it's to Gary's point is that the movements, because there's a whole bunch of factors. There's the focus, there's the seeing, which shakes the star. There's the tracking or guiding of the mount, which is trying to follow the stars, right? And all of those things, and the optics themselves, every optical surface has some tiny amount of scattering that can happen. You've got coma, you've got aberrations, and all of these things add up to basically spreading out that starlight. And the brighter the star is, like this, if you imagine a Gaussian with long tails, and as you raise that Gaussian, the tails get brighter too, right?
Yeah.
And so the apparent size is based on how tall you pull up that essential shape. And it's going to just, brighter stars will always look bigger and dimmer stars will look smaller and tighter.
And here's another interesting story. Sorry to bore you with this kind of stuff, but it is pretty fascinating. One night I was out there doing some imaging and actually kicked the scope. That's happened a few times. So what happens then is the star jerks out away from the big image and then jerks back. And it's surprising. It's a very thin line, and that's the real size of the star that you're imaging. And then it goes back to its bee-like thing making this blob. But if you just kick the scope, you'll see how big it is, and it's very, very, very small.
Kathy and Dennis, you have a question? Could you unmute, please? Should be on the bottom bar. Bottom left. Should be a little mic. There you go.
Okay. So yeah, pretty new here. So I guess the question I have, and it may be kind of been answered with this discussion, is I'm guessing that some of these stars, a lot of the stars we're seeing here are within our own galaxy. When you see images from like James West or Hubble, they have that spiky effect, but none of the images here have that. So I'm just curious as to kind of why that is.
That comes from the diffraction, which is caused by either mirror supports, as in the case of the Hubble telescope. There are 4 mirror supports that hold the secondary mirror, and as light goes around those mirror supports, it causes diffraction, and that leads to the spiky stars. And in the James Webb, the spiky stars come from the segments between each mirror, each hexagonal mirror segment. And so James Webb has a much more complicated 6-sided spike arrangement in the diffraction that comes off of the bright stars. A lot of these images are taken with telescopes that don't have central mirror supports with the cross. Although this one, funny enough, this is a telescope that could theoretically have that, but I think these stars aren't bright enough. So there's another factor with dim stars don't tend to have diffraction spikes. But this was taken with the OGS, which as far as I know should, if pointed at Arcturus or something super bright, it would actually also have diffraction spikes.
Yeah, it would definitely need a little bit more exposure for that to happen.
Yeah.
Good question.
Yeah, the good question. The other thing that I should mention about optics is that there's always this concept of a circle of confusion. In other words, a pinpoint of light in actual fact will be kind of super small, right? But as Brock mentioned, there are all sorts of factors like saturation, movement that would cause it not to be. In fact, here's an interesting fact. When you're actually focusing these telescopes, often you think you're in focus, but you're looking at, let's say, the brightest stars. Sometimes if you focus just a little bit differently, other stars pop into sight. So that's an indication that you probably weren't absolutely focused. When the tiniest stars come into focus, you're very close, if not there. So that's another interesting kind of observing fact.
Just to answer the first question you had, all the stars that you will see in the images are in our galaxy.
Yes.
So you can, when you're looking at the Andromeda galaxy and perhaps Triangulum, you can resolve stars in other galaxies, but in general, whenever you see a star on this image, for example, and the ring nebula itself are all in our galaxy.
Lauri, you have a question.
Yes, I wanted to know, you talked about the single star, and I've heard this lots of times before, is the star in the middle of the ring nebula is the original star that kind of caused the problem. What is the other one that I'm looking at here to the left?
I do not know.
I think it's a foreground star.
Okay, I was wondering whether it was in front or behind or, yeah.
Yeah, it could be. Often you'll see just the single and you don't see the second one. But you're right. It is an interesting thing. I'm not sure.
It wouldn't be in the middle, right? Along with that middle one?
The middle one is the
main star.
White dwarf.
Yeah.
Okay. All right. I just wasn't sure because as David said, I didn't really know about that second star, for sure. So thank you.
Okay.
Perhaps somebody
could imagine a binary star and one went supernova.
That could be.
Can somebody comment on the fact that this ring nebula is likely a sphere? And when you look at a sphere, you actually see it looks like a ring because you're looking through more stuff
Yes,
on the outside edges as opposed to looking straight through it in the middle. Is that's true? Yes or no?
that is my understanding, and it's also similar to what you're seeing with the Cygnus loop and the Veil Nebula stuff, where the edge on the portions that we're seeing edge on are appearing brighter because you are seeing more material.
Yeah. So it's basically a big bubble, right?
Yeah.
Bill, you have a question? I don't think we can hear you. Bill, can you try again? You don't appear to be muted, but we didn't hear you. No.
Okay. Why don't I jump to John's?
You can get your microphone working, Bill, and then we'll come back to your question. Thanks, Brock. Carry on.
Sure. Another one that John took, which is also was done up at the Victoria Center, I believe, but not with a Victoria Center equipment. I think he actually used his own Canon RA and a wide angle lens, but it's still a great spot to work up there at the Victoria Center Observatory. You got this nice shot of the Milky Way centered on, I think, Cygnus. What is it? Yeah. And it's a beautiful shot. Such a nice wide field view. You can see the North American Nebula and Pelican Nebula here, and there's so much going on here. It's a beautiful shot. And then I've got Dave Payne, and here we've got actually a telescope and bright enough stars and a telescope that has 4 vanes holding the mirror, and you can actually see diffraction spikes on this one bright star. I think there's maybe another one over here, but this is a beautiful shot Dave did of I think he called it the Foxicone Nebula. I don't know if that's the official name, but
no,
somebody made up all the names anyway, so it doesn't really matter. Why don't you speak to this one a bit, Dave?
Sure. I was always I saw someone else's image, and I was just fascinated by this because I'm just interested in the flow of material throughout, the flow of gases and of various composition, and how they get thrown around by the radiation coming out of the stars in their midst. And this one's just happens to look, it's associated with a star cluster, which a lot of these nebulous regions are, and that's because that's the stuff that the stars were generated from in the first place. But once the stars form, they start pushing that gas around, and some parts move better than other parts. So you get these sort of fronts of movement and you can see at the front, it's being lit up by the offsetting star. So the radiation is crashing into the leading edge of these gas fronts, if you will, causing them to light up. And then behind them, you get dark areas. And the color itself it's a false color, but it's representative of the amount of sulfur and oxygen ions in the gas, and also hydrogen in the gas. On just a photographic basis, it kind of looks like a Christmas tree, with the stars themselves sort of forming the outline of a Christmas tree. At the bottom, there's a nice fox fur rug that you can sit on and admire the tree. And up at the top is sort of an angel sort of looking thing at the top of the tree. So you got this astronomic and the artistic interpretation.
Perfect.
And so does this have, I guess, an official classification or its name there as the, I don't know if you saw the question in the chat.
Oh, I don't have the chat.
Yeah,
open, sorry.
Dave Noble asked, does it have a, I guess, a
Sorry.
E number or?
It's NGC 2264, and that actually refers to the star cluster and the two nebula that sort of go along with it, although they don't have their own numbers. The one at the bottom is the Foxfur Nebula, and the one at the top is the Cone Nebula.
And I don't know if you saw Les Welsh's comment. Could you say which constellation are these in?
Yes. I usually write that down. I didn't. I will get it for you in a second.
While he's looking for that, as per Leslie's question, Dave just rattled off the NGC, blah, blah, blah. NGC stands for New General Catalog. So that's what we go with, the New General Catalog number, and every object has its own number.
How new is new?
How new is new? Not too new.
It's in Monoceros.
Oh.
And then the next one that Dave did was a nice image of Pleiades, and also known as Subaru, and a whole nice field of dust and gas around it, which is wider field than you often see. It's interesting. Do you want to speak to that one, David?
Sure. I was, most know that the bluish color associated with the Pleiades is because the stars are actually passing through a gas cloud in this case. And the light from the stars are reflecting mainly off of that gas cloud. So unlike the previous one, the gas cloud actually didn't create the stars in this image. The stars are just passing through. But I wanted to show that the star cloud is actually, the gas cloud is actually quite a bit larger in terms of coordinates in the sky. It's bigger in the sky than just the Pleiades. So those are the seven sisters.
Nice image. Whoops. The next one is a planet, and this is one of mine. And I did get a brief amount of time on my telescope pointed at Mars one early morning, a few weeks back, and managed to get a reasonable image. It was a bit blurry, but there's a bit of surface detail there.
That's
So
awesome, Brock. That's just.
I'm looking forward to Mars will be in opposition in, I think, December 8th or something like that. So cross my fingers that we actually get some clear skies and some seeing that's not too bad. And I will get back out there and get a more fully illuminated shot of it.
What does opposition mean, Brock?
Good point. Opposition is kind of like for planets. It's what we call a planet when it's kind of a full moon version of the planet. So we have a full moon when we're kind of directly between the sun and the moon. Well, if we're directly between, we actually get a lunar eclipse. But if we're pretty close to, but not blocking the light from the sun, we'll get a full moon. And the same thing is true with planets, where you'll get a planet that's where where the sun is opposing, and it will illuminate the front of the planet from our viewpoint very completely. Whereas if you look at this image, Mars is not in opposition. So this looks not too dissimilar from a waning or waxing moon, where you're seeing just partially illuminated as the sun is off to the side. And this was done with doing video and then combining the video image frames and stacking them just in a method called lucky imaging, where you're hoping to get as many images as possible, and a few of them might be clear enough that you can get some detail, because with the atmosphere shakes and wobbles the light so much that, you know, normally you don't get, especially where we live, we have sort of mediocre seeing a lot of the times, and so you need to do a bit of work.
Just to kind of point out how difficult this all is, looking through the atmosphere is like looking through 16 feet of water if you're lying on the bottom of a pool. So if the atmosphere or the pool is rough at all, you really can't see too much.
Yes. This next image is a pretty wide field view. I used, I think the equivalent focal length was about 280 millimeters, so it's reasonably wide view. It's a refractor telescope, and so there won't be any diffraction spikes on the stars. And the region is, there's actually a lot going on here. There's the Lobster Claw Nebula here, and the Bubble Nebula. So I can zoom in and you'll see there's the Bubble Nebula. And the Northern Lagoon Nebula is here. And then way over on the side here, there's something, it doesn't seem to have a fancy name, but it's SH2 155, which is one of the other designators that's used. SH2, I think, stands for the sharpless. And that's another designation, the designator for deep sky objects. And this is actually in sort of halfway between, this stuff here is in Cassiopeia, and SH2 155 is in Cepheus. So I guess the border between the two is here, somewhere in the middle. But I thought it was an interesting area, and there's beautiful dusty regions with dark nebulae in between them, and some the reddish regions, of course, are glowing with the hydrogen gas that's been excited by nearby star radiation, and I thought it was an interesting.
Did you see Lauri's question, Brock? She was saying the cluster of stars in the upper left. Do you know what that is?
It is it.
Yes.
No, I don't actually, off the top of my head.
My microphone's working now. It's
Oh,
M52.
good.
It's M52.
Yeah.
The cluster of stars?
Yes.
Oh, perfect. Thank you, Bill.
Cassiopeia is sort of down to the lower left.
Yeah.
Yeah.
Thank you.
Okay, and Bill, did you have a question from before?
Well, I was going to comment about the planetary nebula. Sometimes they're tubes. And so when we see them like rings, we're looking down the tube. So they're not always balls. Because that's why you see some and they're like butterfly shaped or like insects or elongated things. That's you're seeing the tube from the side on. So
any idea what causes that, Bill?
Yeah, I don't really know. I think that's one of those things they haven't figured out quite yet. The way that the jets come off of the planetary nebula or what, like off the star.
Right. Yeah. Well, I mean, you imagine a white dwarf with all that momentum. When it shrinks down, it's going to be spinning pretty fast. So whatever magnetic fields and things would be pretty crazy.
Yeah.
They come in all shapes and sizes. They're actually really nice objects to go after and image.
Yeah. And so that's why when they're elongated, we're seeing them from the side. If it's like when we see, you know, the gamma ray bursts and that, it happens if that beam is, the X-rays are pointed towards Earth. And then they see them. If they're not, the jets aren't pointed towards Earth, they don't see them.
Yep.
Yeah, I really like that area. That lobstery claw thing, I stumbled upon that once up at Mount Cobo. It was like, what is that nebula showing up as I'm panning around the area and had a filter on? And it was like, weird.
Hmm.
Although it's just a tiny portion of it that you pick up in the field of view.
One nice thing as a photographer, when you get a view like this, it just gives you more motivation to zoom in close and get out the bigger scope and have a closer look. So maybe next year or later this year, if we actually get some more clear skies, I'll get in there. And the last image is early on when I was showing Ron's picture of the Heart and the Soul Nebula, I mentioned the center. And this next image, oh, what's going on? It's not changing. Oh, I know why. I wasn't. There we go. So this is actually the center or the heart of the Heart Nebula. So I thought it was a very interesting looking region. This region is basically the center of the Heart Nebula is this collection of stars. I think there's a few others too, but these are young stars and their solar winds and their radiation are pushing out all the surrounding gases and dust and exciting it and making it glow. And it's an interesting area because there's just all these beautiful little tendrils, and it's I just thought it was an attractive looking space. So
It's awesome. It's beautiful.
Yeah, it's a wonderful composition, Brock.
Thanks.
It's just one of these things that it becomes so theatrical because you've got that really dark, really rich foreground and this kind of bright spot in the top. It's perfect.
Thanks.
To the non-photographers, it's amazing how much is actually going on out there, isn't it?
Yeah.
Just astounding. It's a lifetime hobby. You'll never get it all.
Yeah.
For sure.
Now,
There's
Cal,
another
we-
question. Kathy and Dennis.
Yeah, just kind of curious. You mentioned in one of the earlier photographs what kind of telescope was used and what kind of camera, but I'm just kind of curious as to sort of what size of telescopes and camera equipment is used for most of these pictures.
Well, most of them are used with personal sort of consumer grade telescopes or sort of prosumer sort of scale stuff. This was taken with a 9¼ aperture Celestron Schmidt-Cassegrain, and it's a telescope that's easy to pick up, and it's not huge, but it's a decent sized rig. There's been a number of them were just taken with small refractor telescopes. The previous one that I showed of mine was a 400mm refractor, which is not much different than a large camera lens really. And Dave Payne has a 12.5 inch aperture corrected Dalkirkham telescope, which is probably one of the biggest that's any of these images. Actually, Dave's Dalkirkham is also similar in size to the OGS, which OGS is just the brand of, we have it at the Victoria Centre Observatory, which is, I think, stands for Optical Guidance Systems. I think OGS, the company that makes telescopes, but I think a lot of their early work and probably their cash cow is doing work for military tracking systems. I think they did the telescopes used on a lot of the stuff for filming shuttle launches and stuff too. So those things where people sit in the binocular telescope and can aim it around at rockets as they take off down in Cape Canaveral. I think those actually have in the past at least been based on an OGS system. So anyways, those are sort of the rough ranges. I don't know if that helps, bit of a ramble, but.
Yeah, no, that's good. I have a Celestron Nexstar 8 SE Schmidt-Cassegrain. So it's, again, I'm very new to this. I haven't done any art yet. So I was just kind of curious as to sort of what kind of potential capability I would have with astrophotography.
You could certainly take this picture with an 8. Like this is I have a 9¼ I mean, they're practically the same. The focal length is almost the same and the aperture is very similar and same F ratio.
So Dennis, you're probably sitting in the middle in terms of focal length. And for you, if you want to start simple, if you have a digital SLR, you can start there. just attach that to your telescope and away you go. You can get started.
I do. I have a Canon 60D. I think that's what it is.
Yeah.
But I've just bought the rings and the adapters and so forth. So I'm kind of all set up. I just haven't got there yet, but
Well,
I'm kind of excited about trying it out.
Well, join the SIG.
Yeah,
if
join
I
the
have a
SIG. I was gonna
recommendation
say.
is join the SIG, yeah.
Yeah.
Sure, yeah.
But yeah, you've got a great setup too for doing planets. The picture Mars here was taken with that same 9 1/4, so this would be certainly doable. You equivalently done with an 8, you would not see the difference between this taken with an 8 or a 9 1/4.
Oh, that's great.
So I've been trying.
Just so you know, Dennis, obviously we're glossing over 90% of the technical details that go behind these images.
Oh yeah,
if you join the SIG, you can ask all the technical details you want, and we'll drown you in as much as you want to hear. So we do that offline because it scares people otherwise.
Yeah, no, I hear you. Cool.
So if you like the images, what the SIG would like to do is sort of just give probably a smaller update monthly on what's new coming out of the SIG. In the meantime, if you'd like to view the images, feel free to visit the Zenfolio site and leave comments. There's a place to leave comments or questions is great. We really love feedback.
Yeah, sounds great.
And we also, I certainly speak for myself. I enjoy helping others that are interested. So if you ever have questions and you want to reach out and contact me through the SIG or anything else, please do, because I enjoy.
Yeah, so just here's a question. So how do I join the SIG, and how do I know what SIGs are out there?
I think there's a page on our website, is there not, about the SIGs, and then you can click.
There is.
There's a link you can contact.
If you go to victoria.rasc.ca, and I can't remember which pull down it is, but
why don't I just demonstrate that?
Oh, that'd be perfect, Joe. Thank you.
Why don't I unshare here?
And Joe, are you the person that Dennis and Kathy can get an ID for the Zenfolio from?
Yes. Once he starts doing some work, we can set a gallery up for him.
But can just anybody go in there and look, though? I'm wondering.
Oh yes, it's public.
Public, okay, fine.
And he can get on the RASC Astro. I can't remember the name of it.
Yeah, you can just if you just let us know what your email address is, you can be added into the SIG lists, and then the next meeting you'll get announcements and such.
Okay.
Joe, maybe you could show us Zenfolio while you're there as out sharing as well.
That's what I'm about to do.
Perfect, thank you.
So this is the Victoria Centre's main website. And if you go up to media, you'll see there's 2 media sites that we also host, one for photographs and one for video. So the photographs one is where you will find the astrophotographs, and actually photographs and any photographs to do with Victoria Centre. So we also have events here. Any significant event that where photographs are taken, we create a gallery for each one of those. We have a bunch of collections, but the personal astrophoto galleries here is where you will find people's individual galleries where they post their best photographs. So you'll see Ken is here, and Dave and Brock and Dan Posey, all the people you've seen photographs from today are here. Now, Let's get back to our main website. I just wanted to highlight one more thing while I have your attention. And that is under resources, buy and sell. I just wanted to highlight this particular advertisement that was just put up today, because it has a rich collection of Christmas goodies for people who want to buy used gear for astronomy observing. These are not, generally speaking, these are not photographic gear. These are all eyepieces for visual observing. And Bob Drew is from Edmonton Center, now lives in Victoria, and he is regretfully having to sell all his fine gear. So his regret is your gain. Have a look and see. These are all good prices. The eyepieces all look to be in wonderful shape, and they are all premium eyepieces. And that's not the end of it, because we also have other stuff for sale on that page. So you can have a look at that at your leisure. So there's my pitch.
Good pitch.
Oh, did
Yeah,
you
I
have,
love to help people spend their money. So go in there and have at it.
is there a link on the website for the SIGs? I thought there was a page that.
Oh, I was going
there
to
is.
show you that, wasn't I? Okay. Let's go back to share again. Sorry, I got distracted.
While Joe was doing that, who asked where the Christmas tree cluster was? Was it Dennis or was it David?
That wasn't me.
It was you, Dennis?
No, it was somebody else.
David, maybe David Noble. Well, somebody did, and I'll show you where it is after Joe does this.
Okay, so on the main victoria.rasc.ca website, you go under events, and you see the second item there is special interest groups. You get descriptions of each one and who to contact. So you just click on these names, and away you go.
Great.
Okay.
For those who don't know, Bob Drew, who is selling the eyepieces, is the fellow who donated the 32-inch mirror to the Edmonton Center that my friend Roman is building the telescope for.
Well,
He should be just about done. He was hoping to have that scope in place for the Northern Prairie Star Party, but he didn't make it. He still had some issues with some wiring.
Okay, so if it's okay, I'll just flip my screen over.
Yeah, go ahead, David.
Oh, wrong side. Just bear with me here.
Looked to me like you had the right side, Dave.
Did I couldn't really tell.
I saw
Can you-
Stellarium.
Oh, can you see it? Oh, perfect.
Yeah.
Perfect. I thought you were seeing my spreadsheet from sky brightness. So anyways, yeah, so here we go. It's framed by the feet of Gemini and Orion. So this is where the cluster is. Right there.
Cool.
And it makes reference to the cone and also to the foxfur.
Maybe you could post the link to the website for Stellarium, as this is a
Oh yeah, I will do that. I will do that. Actually, here's a plug for Stellarium, even though I really have nothing to do with them. And this is not a diss to my favorite of Sky Safari, but Stellarium is free. So anybody who doesn't own a planetarium program yet, it's a great little program and it's free. And Stellarium Mobile, I have to say, is a very nice phone app. And I just really like how it's been laid out. And I will just leave you a URL to that. I'm just going to stop the share. And I will put in the website for Stellarium.
it's made for multiple platforms, so it is, and RASC National has provided quite a few,
Oh, a lot of training sessions for it
Yeah.
as well.
and some of them have been recorded and can be watched from the RASC YouTube.
Yeah.
Site. If you Google RASC, I think it's, I don't remember what it's called. I think it's something like RASC Canada, where the sea shares between the RASC and Canada. But if not, just look for RASC in YouTube if you want to see what sort of videos have been stored, because since the pandemic began, there have been often 2 or so training things a week. It's tapering off a bit now, but quite a few of those were on Stellarium.
Yeah, Blake from I can't remember which center he's with, but he does a really, really nice job of introducing Stellarium.
Yeah, I think you may be Toronto. I'm not sure.
Oh, he's
Anyways,
moved to London- he's moved to London Center.
Okay.
Okay.
Sorry, dude.
Yeah, anyways, there's the link to Stellarium where you can get the software, and then it looks like there's the link to the webinar.
Chris, could I talk a bit about coming eclipses?
Yes, you may. May I introduce El Presidente?
So do you see time and date up here?
We do.
Yeah, I just wanted to say why I am very sad, but we should all be very sad about those clouds taking about 12 hours too long to get out of our way. So these are the eclipses of 2022. And there was that really wonderful eclipse that people took great pictures of throughout Europe and down to India. And if you like, I can show you some artistic pictures of that I've been compiling. But here we have this total lunar eclipse in the middle of our night, not too practical for timing, but it was going to be just a perfect eclipse for doing something like my crater timing interest. But then what do we get in 2023?
Nothing.
Okay, penumbral eclipse. That means it's not an eclipse. It just gets a little bit faint. You don't care about it. Garbage. There will be a total eclipse in Australia and through northern South America and right up through southern North America. There's this annular eclipse. For us, it will be a nice eclipse. We'll get some great pictures of that if it's clear a year from now. But then after that, it's the tiniest of partial eclipse. Again, not very useful. We might take some nice pictures of it. No, not for us. It's going to be in our daytime. So useless. That's the whole year. 2024. Well, it's really hard to complain because there is a total eclipse coming to Canada. It's going right over my parents-in-law's house in Montreal. And so as long as they have a clear sky on April 8th, I'm certainly going to be there. People who want a better chance of a good sky are going to go down to Texas or to Mexico. Anyway, this is the big deal. There's committees going right across Canada, setting up viewing the eclipse. This is the second great North American eclipse after 2017. But then lunar eclipse, again, partial, and it's really useless. Hardly anything. It's almost a penumbral. Then comes annular, way down where hardly anybody lives, And then there is, I don't even know what it means, lunar eclipse, almost. It's a penumbral. Anyway, it's as far as lunar eclipses are concerned, 2024 is a bust. So we have to go all the way to March 13th, 2025 is going to be perfect, right? But you got to hold your breath till then. So that's our next good lunar eclipse is going to be March 13th, 2025.
Randy, I totally agree. I was looking forward to timing those craters with you.
Let me show you some pictures of the solar eclipse a couple of weeks ago. This is part of my Enkin's Daily Moon. If you just look up Enkin's Daily Moon on Facebook or Instagram, you get a picture of the moon every day that I compile. These are a bit cheeky because you don't see the moon. They're in shadow. When you're looking at an eclipse, the moon is what you don't see. Although this next picture, no, let's go this way. The bumps that you see in the limb of the sun actually are real bumps on the moon. So this person, Jersey leg, oh my goodness, I'm not even going to try. Match them up, just great. This is what people in England got to see. They got to look at the eclipse, a very partial eclipse through the clouds. But that's really fun to do the time series. How about this one? I like it that they labeled it. But it's a really good picture, and to have such a clear horizon, you know, that sun is going through a lot of atmosphere. So Gary said that looking up is like going through 16 meters of water.
Feet.
16 feet of water. That's a really interesting line. I wonder what this would be the equivalent of, though. That's a crazy clear picture. There we are in Egypt. And in India. And in Turkey. I don't know how they do that. They take one picture of foreground and a whole bunch of pictures of the background. Anyway, lovely. In Sweden. Look at that picture with the cranes. That's in India. Somebody was lucky. This was in India too. I love seeing the what do you call it? The heat waves behind the jet engine bubbling up the edge of the shadow there. And a nice time series where they fixed on the moon, so you can see as the transition went. So both the sun and moon are moving, but if you fix on the moon, then you can really see it all the way around like that. So these are pictures that I've been looking at in Enkin's Daily Moon. What am I doing now? Oh yeah, I'm looking at the Great Moon Hoax of 1835. That's a whole other thing. So I'm going to say goodbye.
Thank you. Does anybody else have anything to share tonight? Lauri, yes. You're muted.
Randy, are we going to have a Great Moon Hoax presentation?
Sure.
Awesome.
It was really very interesting little episode. The world went crazy. People actually took it seriously, and there was quite a political overtone to it at the time too. So yeah,
that would be really kind of fun. I just wanted to say to everybody, if you have not been up to the center recently, there's a great deal of construction going on the road. And the entire section, there's an entire one whole part of the right-hand side of the road as you go up is now completely gone. You have to be on the left-hand side of the road only. There is a light that is where it goes green and red to kind of to do the traffic through there. You have to be really careful when you're going through to stay over to the side. I think that you probably know that a year ago or so, when the great big rains came, we did lose a little section of the road to the off to the right. And they have, for a year, they had a couple of bollards there for a while, and then they started working on it. And as they were working on it, part of the road disappeared.
Oh,
And they had to go back in and do a whole bunch more. So it's a mess. So just if you're going up, it's still open and you can still go, although I don't know whether I'd want to go up with the snow today, but just be really careful when you're going up. We're still hoping to have a star party on the 26th of November and on the 17th. Yay, go Nathan. He's going to be our speaker on the 17th of November or 17th of December. Yay. And we're still hoping that, as long as everything is still okay with the road. So we'll keep you up to date on that. We may have to go virtual if things are not as good as they should be. So just.
Yeah, I was going to ask that, Lauri. We're going to do it regardless, right?
Well, we'll certainly do something virtually if we can't get up there. But if you are going up to the VCO, just be really careful. That's all. Okay, thanks.
I'd like to remind people that there will be a council meeting on Tuesday, the 15th. Tomorrow, Jill and I will make sure that the proper announcement goes out.
Yes, thank you. Any further announcements? Well, I'd like to thank everybody for attending this evening, and stay safe in the snow. That's stuff we're not too used to here on the West Coast, but who knows there. So yeah, take care, and have a look at the eclipse if you're up overnight on the live stream. Thanks again, everyone, and we'll see you next week.
Thank you.
Good night.